outside temperature over a day can be modeled as a sinusoidal function. Suppose you know the high temperature is 76 and occurs at 4 p.m. and the average temperature for the day is 60 degrees. Find the temperature to the nearest degree at 5 a.m. So if we want to find a particular time, a temperature at the time, what would be great is if we had a function that if we give it a time, it'll spit out the degree, the temperature in degrees for us. So we need to write that equation, and it is a sinusoidal function. So we need to find the midline, the vertical, the amplitude. We need to find all of that so that we can write down the equation and then use it. We're going to plug in a particular time of interest to us to find our answer. So the function will look something like, and they said sinusoidal. So they want us to write it in terms of sine. So it's going to be y equals some vertical shift k plus a, but it might be minus, we'll see, sine b and x minus h if it has a horizontal shift. Okay, so it's going to look like that format. We just have to figure out what the a, the k, the h, and the b are, and then we'll have our equation. We can plug into it and get our answer. So the a, or actually let's find the k. The k is the midline. That splits our function in half or vertically, and that's it is, you have a sine function. The midline is halfway in between the max and min, because you have a line that is splitting the like I said, in half vertically. So the same distance is here as it is here. So the way to find that is you need to find the number right in middle of the min and max. To do that, you find the average value of the min and max. So to find the average value, it's just 1/2 the min plus the max. So the max value here says the high is 67 degrees. So 67, and the low and average temperature. Oh, and they don't give you average. Okay, they give you the average and they don't give you the low here. Wow, okay, that is throwing us for a little bit of a loop. So suppose you know the high temperature is 67 and occurs at 4 p.m. and the average temperature is 60. So that throws us for a little bit of a loop. So we do not know the min. Sorry. So I plugged. So the min, I'm going to call it the min. And the max is the 76. And that value equals the 60. Well, I guess we don't really need to find the min then. I mean, if we know the average value between the min and max, that's what we're trying to find anyways, that's our midline. So our answer, our midline is 60, our k is 60. Okay, so let's go ahead and try to find the amplitude. That is that's the absolute value of the max minus the min. Because the amplitude is the distance from the max value down to the midline. So that is A. And you could use this equation and say 1/2, but we don't even have a min value. So the best way to find, so let's not use that equation, although it works, but we don't have a min value, so we can't. So we're just going to find the distance between, the high and the average. So it's 76 minus the 60, and that's 16. Our amplitude is 16. right? Then we need to find the B, which is related to the period. So B is the P equals 2 pi over B. If I want to find B, I can remember the related formula that says B is equal to 2 pi over B. Sorry, P. So we just have to figure out what is the period. Well, what is repeating as far as temperature wise? Like, is there a repeating cycle that we can think about? So we think about like the early morning, right? Let's start, I guess, if I start at 8 a.m., right? Then I guess it would probably be on the cold side, so probably colder than average because it's cold in the morning. So if this was our midline 60, 8 a.m. would probably be somewhere below 60, right? And then at midday, like noon, it's warming up. It's probably, oh, that's probably above. It's probably a little warmer than the average temperature of the day. And then at 4 p.m., it's supposed to peak. Well, that's what they say, because the sun is out all day long, and at 4 p.m., it kind of peaks and hits its max value usually. And then it starts getting colder, right? And then the sun goes down, it starts going down basically at around 4 p.m. or so, like the sun starts going down. And then it gets colder and colder and colder. Overnight, it's hitting its min probably near midnight or in the middle of the night, because or I don't know, 4 or 3 in the morning or so, because there's absolutely I'm not getting a lot of sunlight at all at that point. And then it's going to head back up and start getting warmer as the sun starts coming up, right? And so if you look at that, we come back to that 8 a.m. again, where so you have this, and then you have this, and then you have back to that 8 a.m. Then at 8 a.m., it's going to repeat itself. It's going to start warming up again, it's going to start warming up and then hitting its max around 4 p.m. And then, because the new day is started and the sun takes the same rotation around the earth. So we expect a similar thing to happen. At noon and midtime, it's increasing in temperature and then hits max at 4 p.m. probably, and then goes back down right when the sun goes down, right? It's going to repeat itself over and over again in this 24-hour period, right? So this was the first day. In black is the first day, and then in red, you can barely see it, but in red is the second day. Right, so it looks like it's a period of 24 hours until it repeats again. Okay, so that would mean that P is equal to 24 hours. That's the cycle where the temperatures start repeating themselves. They have that same kind of hill and valley again and again. Oh, the period is 24 hours. So that would mean I plug this in to find my B. It's 2 pi over 24, which is pi over 12. So B is equal to 2 pi over 12. Okay, now we think about H. Well, this is our graph. So we could technically let time 0 equal anything that we want it to equal. So if we let it equal, which is kind of hard to do, but like if we chose to let it equal wherever we have a 0 on, or basically 0, or it's hitting 60, exactly 60, then I guess we would say there's no vertical shift. However, I would say let's let it start at maybe midnight, just so that you have the hours after midnight. So because it corresponds to actually the times 1 a.m., 2 a.m., 3 a.m., 4 a.m., and so on. And I would probably say, hey, let's use military time. And I believe military time starts at 1 a.m. and then it goes to 24 hours. So I think that'd be maybe an easy thing to do here. But you can write your equation however you want. I mean, you might write it differently if you wanted to, and to have it start at a different time. But I think this is a good way to do it, so that we want to be able to just plug in 5 a.m. and have it really mean 5 a.m. without having too much trouble. So I'm going to call 0, 0 is midnight, 12 p.m. Then 1 is going to be 1 a.m. And then 2 is 2 a.m. and so on. And 3 is 3 a.m. and so on. And then you'll get to 12, and then 12 will be 12 noon. Oh, I meant a.m. right here, huh? This is 12 a.m. I'm sorry. $12 p.m. and then we'll just call that 12. Will be 12 actually p.m. So 0 will correspond to 12 a.m. 12 will correspond to 12 p.m. And then we'll keep going, and 24 will correspond to 24 will correspond to, I guess that would be another 12, when we go back to 12 a.m. the next day. Okay. So, so when I plug in 24, hopefully that will be 1 full cycle. And you'll notice if I plug in 24, multiply 24 times pi over 12, it'll be 2 pi. So that it does look like it's okay. It's right. Okay. What is the horizontal shift? So I'm going to say that it looks like it's kind of hard to say when the actual min, and okay, they tell you the high occurs at 4 p.m. Okay, so they do tell us that. That means that I remember I told you that like the min and max, they take place in the min and max are exactly 12 hours apart. I'm sorry, they're half the period apart. So half of the period here, half of 24 hours would show you that there's 12 hours. So there must be 12 hours between the max high of the day and min of the day, which makes sense. So if the max occurs at 4 p.m., then the min occurs at 4 a.m. So showing us that it might be a good idea to let this equation it looks like that maybe it's shifted by 4, right? Because it's looking like it's going to start at its min value. It's going to go up. Oh, sorry. Yeah, it's starting at its min value at 4 a.m. So let me. So here's 0, 1, 2, 3, 4. It's starting at its absolute min value at 4 a.m. And then between 4 and 4 p.m., 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this would be 4 p.m. It's hitting its max value. So in between, it's going like this. So a fourth of 24 is 6. If I broke that period into if I broke that period into 4 equal pieces, so 24 into 4 equal pieces, that would be 6 hours. So it's going to hit another like crucial point in its graph in another 6 spaces from 4. So that would be over here. There's no -2 hour, but I'll just draw it. So that means it's going 6 spaces. So let's just look at cosine as regular sine. A fourth of the way through, it's traveling, it just makes it from 0 up to the max, a fourth of the way through. Or if we look at this fourth of the way through, it's going from 0 to the 0. I'm sorry, from its max to 0. Or at this fourth of the way through, it's going from its 0 to the min. This fourth of the way through, it's going from the min to 0. So it's only going to travel in this next fourth back to the 0 line. So it's going to go like this. It's not going to get to its max. It's just going to hit its midline. And it won't be until another 6 hours in this direction that it hits the full max again. So our graph will kind of look like this. And this will be 60 degrees. So it's looking like if this is a sine function, it's looking like it's going to hit this 0. I want to really know where it's hitting 0 on the mid. Well, 0, I call it the 0, but it's like where it's hitting the midline. And it looks like it's going to hit that midline at -2. So it looks like this picture, it should have hit the regular cosine would have hit 0 at right on the y-axis here, but it's hitting it that way. So it looks like it got shoved back 2 spaces. So I'm going to say that this was a -2 horizontal shift here. So now I think we have all of the components that we need to write this final equation. So it's y is equal to k, which we said was the midline, which is 60. So I'm just plugging into this equation, okay? All right. Now, also note that look at how this function goes, that it actually starts at 0 and goes down to a hill first, or sorry, goes down to a valley, then goes up, starts going up to a hill before it goes through one full rotation, which would be in another 6 hours here. For it to come back to the midline again, right? Because I said it's a 6 hour period where it goes from max to 0, and 0 to is a 6 hour period. So these are equation 60 plus the amplitude we saw was 16. And let's look at this. If I write the equation as being moved 2 spaces to the left, then that means that this is not positive sign, it's negative sign, right? Because it's flipped. It goes to a valley first here and then to a hill. So we're going to say negative 16 sine. The b is pi over 12. And the h is negative 2 here, because it moved 2 spaces to the left from where we would like that, or where the picture should have been if it started if it started on the right place, the y-axis. So I simplify it, and this is our equation: 60 minus 16 sine pi over 12 x plus 2. Okay. So now we need to know what the temperature will be at 5 a.m. And so we already designed it so that we can plug in a particular value. So we just plug in 5 for x. And there's 2 variables we can plug in for, y or x. Y is our degrees, and x is our times. So we could have said t and maybe 8, I don't know, big T of t or something like that, but we just used x and y. It's fine. So let's actually evaluate and see what the value of the function really is at that time. Looking at my graph, it should be at 5 a.m. This is 4 a.m. It should be a little bigger than its minimum value. We never calculated the minimum value, but so 5 plus 2 is 7, so it'll be 7 pi over 12 sine, it'll be negative 16 sine 60 minus that value. So I just use my calculator and I just calculate what that is. It's 60 minus 16 sine of 7 second pi divided by 12. Make sure to put that in parentheses. And I make sure to put that, we want to have this in, it's going to be calculating, let's make sure our calculators are in Radian mode. This is whenever we're doing these types of problems, these application type problems, it's probably a good idea to stay in Radian mode, because we don't want to, we need to make sure that there's no units within the argument here. So I plugged in a time. I don't, if we have to plug in degrees here, then we would use degree mode. But if you plug in anything else like a time or anything like that, you don't want degrees in this, you want this equation just to be in time and not degrees. So that's why we use radians, because radians are unitless and they don't have degree measurement. So, okay, so this looks like, let me just, that looks like that is what we're looking for. That looks like our answer. And so, wait a second. I'll double check that. Yes, that is the answer you want. 45.54. And just to kind of visually show that makes a good answer, is because they're giving us a time at 5 a.m. And like I said, 60 degrees is the average temperature. And we said the amplitude was 16, so that would make the min value, let's subtract this, 4, so that would make the min value is 44. So like I said, at 5 a.m., it's very close to 4 a.m. It's very close to the min value time. So we expect that it's just a little bit warmer than maybe 44 degrees, which is exactly, I mean, it's only a half a degree warmer. And it's only 44.5 degrees. So that's to be expected, because this is the point we're looking at. It's like this is 5 a.m. and it's very close to the min value. So this sounds like a reasonable answer, this 44.5. Do make sure when you put your answers in that you are rounding to the correct number of decimal places. So just like they say, find the temperature to the nearest degree. So they would actually just want you to do 45 probably, and I think they probably would accept the answer of 45, even though they have a more exact answer as, so let's just, yeah, they would accept 45, even though they have it more accurate, they will accept it to just a degree. All right, I hope you found this valuable. Have a great day. Bye-bye.